Hi, everyone. My name is Zoe. I'm here today with my colleague Ron. We are going to present using the multi-modal microsimulation to evaluate a hospital traffic operations. So first, who we are, who are these two human beings? Ron and I are with Spear and Pierce from our Bay Area offices. Ron is one of our traffic operations practice leaders in our company. He has been working with PTV software for over 9 years. And my name is Zoe. I've been using Vism for 1.5 years and I really enjoyed a lot working on freeway operations and multi-modal Vism projects, as well as traffic signal design projects. That's enough about us. So we can talk about the project. Today, we're going to talk about one of our typical traffic impact studies done in the Bay Area. The project was, we're highlighting today is about a hospital expansion. This project has not been complete yet, so we won't be able to disclose a lot of details and results due to the confidentiality required by the client, though we thought we would be done when we signed off the projects 2 months ago, and we all know it's never the case for a Vism project. First, we want to touch base on the existing streetscape of the project site. It is a hospital in the city in a really dense urban area on a two-way major street, the First Avenue, as you can see on the Google Maps snapshot that we attached at the bottom, this is an avenue that was public on-street parking in the curb spaces. There is a good amount of public transit stops along the street. TNCs drop off the passengers in the travel lane, blocking the traffic. There are pedestrians crossing the street with very limited traffic control devices. In a word, it is a busy street, and it is really challenging to make improvements to the streetscape. And the pedestrian safety is one of the priorities of us and our client. Next slide. So the project itself is building a new hospital to its existing highly utilized campus. The new hospital will increase the inpatient bed capacity by 37%. And we expect near about 15,000 additional person trip, which to some degree correlate with the vehicle trip, excluding those trips completed by taking the public transit. We also expect this ambitious expansion plan is going to generate multimodal computation for its very limited transportation infrastructure. So the client is really seeking for countermeasures to address the pedestrian safety concerns. And now I'm passing along to Ron, and he's going to share our modeling considerations and Vism implementations.
Thank you, Zoe, for introducing the project. Hello, everyone. Well, what did the client requested from us? The client was very interested in fully replicating multimodal activities, special TNCs in the area. So I described current TNCs are just blocking the lanes while they are dropping or picking up passengers. Try to figure out cost-effective roadway and pedestrian infrastructure improvements, and then support the parking design layouts, with feedback on how many parking spaces they need. And then the main one is the hospital stakeholders. They are not engineers or planners, so they really wanted to see visualizations to better understand the recommendations that we were making. Okay, so how do we deal with our traffic impact studies? Of course, the core analysis is going to be done in Vism. We use Bistro for project generation, distribution, and assignment. Visum, with the help of T-Flow Fuzzy, to come up with static routes to be used in Vism. So this is the sequence of how we traditionally do these kind of projects. We develop the network in Vism. Once that is at a 95% completion, we load it into Visum, take advantage of the turning movement counts, OD estimations from street light data to use T-Flow Fuzzy and provide static routes that are going to be reported through coordinate system into Vism. We calibrate the existing conditions and then bring the project information, the trip assignment into BISM to go ahead and have fun with the project alternatives. Okay, so what we did in BISM. First of all, pedestrians, most of our data was collected at the intersection level. But given that the client was asking for videos, we noticed that if we actually bring BZoom with areas and obstacles and just extend this sidewalks through strategic pedestrian routes, we can give that reality when we do the videos for the corridor. And then, of course, so I mentioned, one of the challenges, the pedestrian safety. So it was a must for us to use some links so we can use them as pedestrian areas and simulate pedestrian and vehicular conflicts. Okay, as I mentioned, here we have about 35 pedestrian routes for a total of 88 destinations. Again, just stretching the locations of the static routes allow us to provide that visual requirement that the client wanted. Here is one of the examples where we converted the link into a pedestrian area to code use conflict zones, and then provide more visualization, appealing by connecting the pedestrians with transit through waiting areas and platforms. Okay, so now jumping onto how we did transit and TNCs. Of course, we use public transport lines and stops for the hospital shuttles and Muni. There was some ridership data that provide us with better information on how many pedestrians were boarding and alighting. And then one of the key assumptions that we suggested to the client is we can contact Uber. We can talk to the vendors to develop TNC geofence, so that way they are not blocking the intersection. So that was one of the big assumptions we used for this study. A little bit more details of the transit. We had 8 transit lines, but the reality is that mainly were 4 because we use, like I mentioned, Muni and the hospital shuttles for the eastbound and westbound directions. And then we just had 4 ambulance routes because, it's a hospital. So we wanted to introduce the ambulances for video purposes. And then that allows us also to have some fun with how pedestrians get in and get out from the buses. The way that we coded the TNCs is we use parking routes. One of the keys for us was to code the TNCs with different vehicle classes, so we can easily connect it with the parking routes and separate them and allocate them to the blocks that we want them to go. And then, of course, we have different time distributions at the different parking locations, which have different parking purposes. Now I'm going to turn it back to Soy, who's going to cover the design alternatives.
Thanks, Ron. So we utilize the scenario and modification manager to keep track of the existing plus the project, existing plus project with the mitigations, future no build and future design alternatives regarding the hospital loading loop geometry design. So the hospital expansion includes the construction of 2 new loading loops at the hospital entrance. Given the nature of the project, as it is still going through the design stage, so we've been setting up a modification for 1 design alternatives. So we were able to share the results with the client, also leaving some space for a good amount of design iterations in the future. So here is a preliminary 3D animation video that we took from our vision model. As you can see, the video captures the signalization of 2 adjacent intersections by the hospital, and we proposed the high visibility crosswalk along the corridor, since these are the places that have really high pedestrian activities. We also took the opportunity to use the vehicle types to color-coded different vehicle types, where the black is, I believe, the on-street parking vehicles, red are the buses, the yellow one are the TNCs. You may also notice that there are two pretty wide crosswalk, which we will touch base later. And we were also able to show the pedestrian just using the sidewalk and cross the crosswalk. So how did we utilize the results from VISM to inform our transportation recommendations, and how do we transmit the message to the stakeholders and the community? So here is an example of pedestrian improvement recommendations that we provided. The first improvement we explored is widening the existing crosswalk, which is shown in the center of this figure. Because this is the main pedestrian entrance adjacent to the hospital, with the pedestrian demand that we put into the model with the existing narrower crosswalk, which is typically 11 to 12 foot, the pedestrians just queued up and could not make it to cross the street. So we decided to propose these recommendations to expand this crosswalk to be 80 foot. Yeah. So, and the next, oopsie. Sorry, that's a teaser. We also suggested signalizing the adjacent intersection to the right, that is by the exit of the emergency department loop. Not because the signal is warranted there due by its peak hour vehicle volume, but again, due to the high pedestrian activity in this area, and the pedestrian safety concern is one of our client and ours top priorities. We also explored relocating the bus stops to the green blocks location as shown in the graphic. It is on top of the main loop in the graphic. So also restricting the public parking on the south side. As such, if there is a queue, the bus will be able to jump them, not fully a queue jump, but will save a good amount of time for the public transit. And similarly, on the north side, given the proximity to the main entrance to the hospital, we added a TNC area, which is shown as valid, but it's actually TNC. If the bus got lucky, they were able to make, there were enough space for them to make into that area, then it will also get a more time saved on the public transit end. And here is another example on the loop design side. The new hospital, as we mentioned previously, includes the construction of two new loops, one for the main entrance and the other one is for the emergency department entrance. Both of them will be served as the pickup drop-off area and including some of the short-term parking. The drop-off area was exploring a lot of different ways. With the challengings being on the demand side, particularly on the usage type. So imagine that if people are dropping off a family member or a close friend, they tend to spend more time just dropping off the passenger with more patient and gentle, versus a TNC drivers are likely to be more efficient on dropping off the passenger. So we were able to explore different dwelling time distribution groups. So the groups that we look into is vehicle drivers that are spending dwelling time under 2 minutes, with a group of spending time 2 to 5 minutes, and those spending time longer than 5 minutes. And some of the alternative explore dual lane parking, which is they have 3 lanes, and for 2 lanes that are closer to the hospital site will be used for pickup at drop-off, and the 3rd lane will be used for passing either to the emergency loop or exit to the intersection. And we've noticed from the model that the vehicles were rejected by parking spaces because of the insufficient use of the parking area. So one recommendation that we came up with is implementing the active management of the loop. So having someone waving the drivers out, so the cars went queued up, waiting for the parking spaces being available, and then the queue went spill back onto the major street. So it will prevent having effect on the major corridor. So here is a nice summary of our recommendations on the curb spaces reconfiguration. We don't want to go into too detail about this, but just want to remind ourselves that the existing curb spaces are on-street parking and really constrained. And now we are dealing with even more TNCs, public transit, and a higher pedestrian demand. So what we recommended here is we separated hospital shuttles and the public transit bus stops, providing more ADA parkings and the designated passenger loading zones to create a more suitable space for various use of the street. And here is another great summary slide consisting of all of the treatment that we just mentioned along the major street by the new hospital, including some new bus bulbs and the separated shuttle stops, installing the high visibility crosswalk, and also installing new signals at those major intersections. And that comes to the conclusion, and let us know if you have any questions, and feel free to reach out to Ron and me by the email.